Use the points 0, 2, 2, 8, and x, comma y on the blue line in the graph below to complete the equation. And they have this first equation, y minus 2 over x is equal to blank. And then they say write the equation of the line in the form y equals mx plus b. So we have a line here, and they give us two exact points, and then they tell us one general point in terms of x comma y, although the way they've drawn it on the diagram, it looks like it's the point -3 comma -7, but we'll just assume that we don't know what those are, that those are just two general points. And what we want to do is figure out what this ratio is, and then we need to figure out the equation of the line. Well, a good place to start is just figure out the common ratio between our change in y and our change in x between any 2 points in the line. So let's think about that. If I were to go from point 0, 2 to point 2, 8, what's going to be my change in x? So my change in x is just like that. So my change in x is equal to, well, to go from x equals 0 to x equals 2, you had to go up 2 in the x direction, or you have to go to the right 2, I should say, in the x direction. And our change in y, well, we're going from y equals 2 to y equals 8. So our change in y, if you're going to go from 2 to 8, your change in y, remember, triangle y just literally is the Greek letter delta. Delta y is just a shorthand for saying your change in y, well, I went from 2 to 8 is equal to 6. So if you constructed a right triangle like this side's length is 6, this side's length is 2, and the ratio of this height to this base is going to be the slope of your line. So delta y over delta x is equal to 6 over 2, which is equal to 3. So what do we do? What do we do with this? How does this answer either of those questions? Well, this ratio, your change in y, your change in height versus your change in the base right over here versus your change in x is going to be constant for any right triangle constructed this way on this line. So for example, when you're going this right over here, y minus 2 over x, let's think about it a little bit more. If I were to go from the point x comma y to the point right here, which is the point 0 comma 2, what would my change in x be? So my change in x is going to be equal to, well, if I end up at x equals 0, and I started at x, so I end up at x equals 0, and I started at x, my change in x is going to be 0 minus x. And if that doesn't make a lot of sense, just think about it. If x is -3, then our change in x is 0 minus -3, which is 3. The length of this side of the triangle right over here is 3. Now, let's think about the height, our change in y. Well, our change in y, we end up at a y equals 2, so it's going to be 2 minus whatever our original y is. And it looks like, if you just eyeball at this point, it looks like it's at about -7. And if you have 2 minus -7, you get 9. And this indeed has length 9. So this ratio, delta y over delta x, should be constant for any right triangle constructed like this, where the hypotenuse is the line itself. So delta x over delta y, delta y I should say, delta y over delta x, the ratio of this side to this side is always going to be the same. These are all similar triangles. It's going to have the same ratio as this right over here. So change in y is 2 minus y. Change in x is 0 minus x. This is going to have the same ratio. It's going to be 6 to 2 or 3 to 1 or just 3. Now you're saying, wait, Sal, that still doesn't answer my question. Even if I get this 0 out of the way, I could write 2 minus y is equal to negative x, or 2 minus y over negative x is equal to 3. But how does this get us this ratio right over here? Well, if you multiply this numerator and the denominator by a negative sign, so if you just multiply the numerator and the denominator by a negative sign, as long as you're doing the same to the numerator and denominator, you're not changing the value of this expression. In the numerator, you'll get y minus 2, and in the denominator, negative 1 times negative x is x. Well, that's still going to be the same ratio. That's still going to be 3. So this right over here is going to be 3. Then they say write the equation in the form y equals mx plus b. So when you have an equation in the form y equals mx plus b, this term right over here, this is that ratio we've been dealing with. This says, hey, every time I increase x by some amount, how much am I increasing y by? This is your slope here. And so we know that this is going to be of the form, y is equal to, I want to do in that black color, y is equal to, our slope for this line is 3, is equal to 3x plus b. And now we have to figure out what b is. And what helps us in this is to recognize that they've given us several points. They tell us what happens, well, when x is 0, y is 2. When x is 2, y is 8. So we can use any one of those points to solve for b. I like using x equals 0, y equals 2 because it cancels this term out very nicely. So we know that when x is equal to 0, y is 2. Or we could say when y is 2, or when x is equal to 0, y is 2. So 3 times 0 plus b is going to be equal to 2. Well, that's just 0. And you're just left with b is equal to 2 or 2 is equal to b. So we're done. It's y equals 3x plus 2. So let's fill that in on the actual exercise. So this ratio is 3. It's the ratio between a change in height over a change in x. That's constant across the line. When you construct a right triangle, they're all going to be similar. They're all going to have that same ratio. And then the equation of the line in that form, it's y equals that change in y over change in x, that constant ratio, which is defined as slope, 3x plus 2. This 2, which is where you intersect the y, what is the value you get when x equals 0, that's often called the y-intercept. Because you see, you intersect, when x is equal to 0, that's when you intersect the y-axis. So y equals 3x plus 2, and you can verify that any of these points will satisfy this equation. And we got it right.